Today, we want to look at more at using trig ratios. We want to go over this again. This is an important part of what we do here in trigonometry. We have these trig ratios because I want to be able to understand all the measurements in a triangle. And the tools we had before trig were just sum of the angles was equal to 180 degrees and the Pythagorean theorem. One thing that only had angles, one thing that only had sides. I needed a way to combine those two things. So that's where trig ratios show up. Now we have our three most important trig ratios. Sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, tangent of theta is opposite over adjacent. This is specifically the definitions of our trig ratios in a right triangle. Right triangle. We know we're talking about a right triangle because we are talking about hypotenuse. So we can use this to make these trig ratios establish a relationship between angles and sides. So given two pieces of information, we can find a third piece of information about the triangle by rearranging these things. So if sine of theta is opposite over hypotenuse, I can rearrange this to figure out what the opposite side is. So this will tell us that the opposite, if I multiply both sides by hypotenuse, opposite is hypotenuse times the sine of theta. I can also rearrange this to solve for the hypotenuse. If I take that hypotenuse times sine theta equals opposite, I put the sine of theta underneath the opposite, and I can see that hypotenuse is opposite divided by the sine of theta. I don't want to remember this as three separate things. I want to remember this as one thing that we can rearrange if you understand how multiplication is there. But I could use this to relate an angle and the sides of a triangle. One of the things that we came across last time was that if we want to use these trig ratios to find angles, we need to undo our trig function. We need to inverse trig functions. So the other thing that we have to have is that if sine of theta is opposite over hypotenuse, then theta is sine inverse of opposite over hypotenuse. We need inverse trig functions to solve for angles. So we use inverse trig functions to find angles. The ratio itself is the sine of that angle. I need to be able to undo that. And so I use an inverse trig function. The same way we do with multiplication and division. If I have solved the equation that says 2x equals something, the 2 is included by multiplication, I do the inverse of that. I divide by 2. If the x is being cubed, I do the inverse of a third power with a 1/3 power or a cube root. So we just want to make sure that we can rewrite these and use them to find other parts of triangles. So if cosine of theta is adjacent over hypotenuse, then the adjacent side is the hypotenuse times the cosine of theta. Or I can say that the hypotenuse is the adjacent side divided by the cosine of theta. Or I could use this to find an angle and say that theta is cosine inverse of adjacent over hypotenuse. We use inverse trig functions to find angles. For tangents, tangent's the one that doesn't involve hypotenuse. The hypotenuse part is kind of implied because I've got names for two legs. I'm using the word adjacent. That means the third side of the triangle must be the hypotenuse, because there are always two sides that are adjacent to an angle. But in a right triangle, one of those sides will be called hypotenuse, so I can give names to the other two. In this case, I can solve for the opposites by multiply. Opposite is adjacent times the tangent of theta. We can also solve for the adjacent by saying adjacent is opposite divided by tangent theta. We can also use this ratio to solve for the angle with an inverse trig function. So theta itself will be tangent inverse of opposites over adjacent. We use inverse trig functions to find angles. Most calculators have multiple functions for their buttons. And so most often, if you have sine, cosine, and tangent buttons, you're looking for the second function. The button on your calculator that says second. You press second and then the trig function to get the inverse trig function. How's everybody okay? You look so very happy. You all look like this. I decided that means happy. Retirement plan is very simple. It is trying to figure it out. My retirement plan is good. I'm not going to open an insomnia clinic. The great thing is, I won't have to pay anything about what I do. I just have to get comfortable seats and soft lighting. And instead of using like the caffeine infused voice that I normally have, just switch back to soothing voice. So imagine soft lighting, like soft, warm lighting, like comfortable chairs instead of these hard plastic ones, like soft, comfy chairs. And then go have the door, talk my way through this. We're going to talk about how about that? It's only from side. Forget those little wave machines. Maybe I should just record it. Alexa, play me some Trigonometry. Take the NPR voice and just soften it up around the, you know what I mean? Bring the tone knob up a little bit. The NPR voice, soften it up. Perfect. All right. So remember that to use inverse trig functions, we're going to have to press the second function button on our calculator. Also, when we're measuring angles, we have to make sure our calculator is in degree mode. We have multiple ways of measuring angles. Degrees is but one of them. So if the answers aren't coming out as expected, check to see that your calculator is in degree mode instead of radian mode. By way of practice, I want to practice some problems. So I've got some practice problems for us. Is this the one? This is the one. So one of the things you may notice is that I like to have practice problems in class. So you get any questions answered, you get a chance to practice doing the calculations. Whenever there's a set of practice problems, within a day or two, they'll show up on Canvas and they're going to be the same problems. It's just a place for you to enter in your information to make sure if we didn't get to all of the problems, that way you can verify your answer. So on Canvas, these problems will show up. These problems will show up on the Canvas. All right, so let's take a few minutes and practice using opposite, adjacent, and hypotenuse and our inverse trig functions to find the parts of the triangle. What we want to think about here is, what we want to focus on is what the given information tells us about which trig ratio we're going to be using. Notice that the problems 1 and 2 both deal with the same triangle. Problems 3 and 4 both deal with a second triangle. And problems 5 and 6 deal with a third triangle. I've got 3 different triangles. I want you to look at the given information that you have in the odd number problem. And then think about how that changes how you can answer the question if you look at once you have the even number problem. I want you to think about what changes as soon as you get one extra piece of information. All right. So let's take a few minutes and answer these 6 questions about the 3 triangles. I'm going to pause the video, so we'll come back in the next video. Come back for part 2. Welcome back. Let's take a look at the problems, the practice problem. Now, we don't just want to solve the problems. We want to think about what we have to do to solve the problems and what our options are. So the good news is that a lot of times when we're doing problems in math class, we have options. The bad news is a lot of times when we're doing problems in math classes, we have options. So yeah, it's great, but sometimes it's kind of a pain in the ass because then we have to decide what we're going to do in a particular situation. We all think we want lots of choices until we have lots of choices and we have to make one, right? All right. I mean, that's like the source of FOMO. It's like, oh, did I make the right choice? All right, let's take a look at what we're given. So we have given information. I'm looking for theta, and I've got 3 pieces of information. I've got the side opposite theta is 12, the side adjacent to theta is 5, and we have that this is a right angle. So I want you to notice this is 3 pieces of information. I've got half the information about the triangle. So note, we have 3. We are given 3 things about this triangle. Number 1, it is a right triangle. So there's a right angle. And we have the side opposite. And the side adjacent. Given these 3 things about the triangle, right angle, opposite, and adjacent, what do we kind of have to use? What's our only option to find a 4th piece of information about the triangle? Sine requires hypotenuse. We don't have that. That opposite and adjacent is the only option. Tangent. Our only option is to use tangent because I have opposite and adjacent and right triangle. So the only option for a 4th piece of information about this triangle is to use tangents. I'm looking for theta. I have opposite, I have adjacent. That tells us to use tangent. And at this point, that's the only option. We are looking for an angle that tells us that we're going to need an inverse trig function. And I picked tangent because I knew it would be written right above. So even if I had to scroll, you'd be able to see it. So I'm going to say that tangent of theta is opposite over adjacent. So theta is tangent inverse of opposite 12 over adjacent 5. And I'm just going to plug that into my calculator like it shows. Notice that when I first did this, I got 1.17. I said, there's no way this is a 1.17 degree angle. So I went into the mode and I changed my calculator to degree mode. And so the tangent inverse of 12/5 is 67.38. I can't remember if I said round to the nearest 10th, but let's round to the nearest 10th and call it 67.4. We had three things about the triangle to start: the right angle, the opposite, and the adjacent. That forced us to use tangent. We had no options. You have but one choice. You have zero choice. Let's pick over here. Let's see if it's again. I don't want to be like automatic. You have but one choice. Funny photos of actually that means you don't have a choice. I don't think if Frodo would have said that. I think that's definitely like Mary would have said that. Mary would have said it and people would be like, oh, hell yeah. So the only option to find a fourth part of the triangle is a tangent of theta. Is to use tangent because we have opposite, adjacent, right triangle. That's the three. Only tangent for an option. So we use inverse tangent to find an angle. And now we have four things about the triangle. Now we have four things about triangle, which means we have options. The next part of the problem said, what is the hypotenuse of this triangle? I'm going to play the percentages. What did you use? Now, even though with this four things, what did you use to find the hypotenuse? So now that we have four things about the triangle, we have options. Now that we have four things about the triangle, we have options for finding the fifth and sixth things. Most likely what we did at this point, since we have the 5 and the 12, is to use the Pythagorean theorem to find the hypotenuse. So 5 squared plus 12 squared is the hypotenuse squared. So the square root of 5 squared plus 12 squared will give us the hypotenuse, which is 13. Or maybe you immediately recognize this as a 5, 12, 13 right triangle. Did anybody recognize the 5 and 12 and put the 13 in there? Some of you are like, oh, yeah, of course I did. 13, 10 minutes ago. So this is probably the most likely thing that happens, is to use the Pythagorean theorem. Now I've got that's so now we have the hypotenuse. That was problem number 2. That's not the only thing that we could have done, because now I have an angle theta. And sine and cosine both involve the hypotenuse. So I could use sine and cosine since I have an angle. I can use sine and cosine to help me find the hypotenuse. So I use the Pythagorean theorem, but we could also have used the sine or the cosine. Oops. So here I did the square root of 5 squared plus 12 squared. 13. Oops. All right. Now that I have theta and the opposite and the adjacent, I could maybe say sine. Oh, I missed the colors already. Sine of 67.4 is equal to opposite over the hypotenuse. So this would be another way that we could find the hypotenuse. So just following the map that I have up here, hypotenuse is going to be the opposite divided by the sine of the angle. So I can grab my calculating machine and take 12 divided by the sine of 67.4. Why did it come out this and not 13? I mean, if I round it to the nearest tenth even, I get 13. Why did this not come out exactly to 13? What happened? Is the calculator wrong? Am I incorrect in saying that we could use sine to solve this problem? What's the problem here? Yeah. It's because the angle was rounded to the nearest tenth. I didn't use all of the 67 point whatever. I stopped at 67.4. The angle has been rounded off. So even if we rounded this to the nearest tenth, I'm going to write down more digits to emphasize. Five goes together. So emergency, we didn't get the same thing. The reason that we have to round our answer to get to what we want is that the 67.4 is a rounded off value. When we used 5 and 12, those were given, those were exact, but the 67.4 has been rounded off. So by rounding the angle, we've introduced rounding error. Now, if I had used more digits, instead of 67.4, if I had used all these digits and said 12 divided by the sine of this angle, then we do land exactly on 13. Use all the digits that the calculator has, then we'll get it right where we expect it to be. Any questions? If you can avoid using rounded information, then you should. Now, I've happened to pick sine and said sine of 67.4 is 12 over the hypotenuse. So the hypotenuse is 12 divided by the sine of 67.4. But the same thing happens if I take 12 and divide it by, 5 and divide it by the cosine of 67.4. I'm a little off the other way because the 67.4 has been rounded. But if I use unrounded information and then do 5 divided by a cosine of that angle, then we land exactly on 13. Yes. To get A and S, it's right above the change the sign button on this calculator. It's hard to see, but there it is, A and S. So to get that, it's the second function of the change the sign button. Okay, so good news is we had options for solving the problem once we have 4 pieces of information. Bad news is we've got options for solving the problem once we have 4 pieces of information. That means you have to make a decision. As far as making that decision goes, my recommendation is to try to use unrounded information whenever you can. But if you have to, use lots of digits. Don't round off before you get to the end. Let's take a quick break, come back and do some more problems.